You've covered APIS well. Now let's talk about security. How do you implement authentication and authorization in your .NET applications? Can you explain it with a real project example?
Absolutely. Security is a foundational pillar of every modern application. In .NET, my go-to setup is JWT-based authentication combined with role-based authorization. And for more advanced control, we also use claims-based or policy-based authorization when needed. Let me share a real example from a university portal I worked on. The system had 3 roles: students, faculty, and admins, each with distinct access levels. Step 1. Authentication with JWT. When a user logs in with correct credentials, our backend generates a JWT token. This token includes information like the user's ID, their email, and role, all securely signed. We then send this token back to the front end, and for every future API call, it's attached using the HTTP header for authorization under the bearer scheme. Now, on the back end, specifically in the startup configuration, we enable JWT authentication using the built-in JWT bearer scheme. We also set up token validation parameters to check things like, is the token coming from a trusted issuer? Does it match the expected audience? Has the token expired? And is the signing key valid? We generate this signing key from a secure value stored in our configuration settings. That setup ensures only properly signed and trusted tokens can access protected resources. Step 2. Role-based access control. Each user is assigned a role, say student, faculty, or admin, and we embed this role directly inside the token at log. On the API side, we restrict access using attributes. For example, if we want a particular endpoint to be accessible only by admins, we decorate it with Authorize for users with the admin role. This way, anyone who doesn't carry that role claim in their token, say a student, gets blocked automatically. Step 3. Claims-based access for fine-grained control. Sometimes roles alone aren't enough. Let's say a student wants to view their marks. We don't want them seeing anyone else. So we extract their user ID from the token using a claim like NAM identifier. Then, in the service layer, we filter the data based on that ID, ensuring they only access their personal records. This approach allows granular data isolation while keeping the logic clean and reusable. Step 4. Security best practices. We didn't stop at just auth. We hardened the system by implementing key best practices. Forced HTTPS for all communications. Defined strict course policies to allow only trusted domains. Used anti-forgery tokens for sensitive operations in web apps. To strengthen session security, our tokens were valid for 30 minutes. And to avoid frequent logins, especially for faculty who stay logged in during lectures, we implemented refresh tokens that silently extend the session. Final layer, monitoring and audit logging. We added structured logging using Serilog to monitor all login attempts and access failures. This included recording IP addresses, device and browser details, request paths. These logs helped admins track usage and detect any suspicious behavior. In summary, we used JWT tokens for stateless authentication, role-based attributes for access control, claims to filter user-specific data, and followed strong security hygiene from HTTPS and token expiry to cores and logging.